Hello Professor, my name is Muhammad Al-Jahani, student ID 1011970558. This is my video submission for assignment 2. The first part says upload the iris CSV file into your Google Drive using import Banda and import NumPy. And then we have right here, read the content of the iris.csv file and save it into a variable named iris. So here's the variable name, and then we read it using pdread right there. Now we have show the first 5 rows of the data frame. We use the head function to show the first 5 rows. And then question 2a, please convert the last 2 column strings to integers. To convert, we're going to use .map, and then we put the variable name and then the value. And to be check the first 5 elements of the iris dataset. Once again, same idea, using the head function. It checks the first 5 elements. And then for 3a, we use x.iris lock, and then we have the -1 here that represents the last element, because it says here select the first 4 columns. We have 5, so the last one, the 5th one, will be represented by -1, and this line will show everything except the last line, and this one will show only the last line, which is represented by this right here. And then we have split the data and label into training and testing segments. So to split data, we're gonna set, it says here, set the size of the data to 20%, which is defined here, 0.2, and then 123 to make all the answers similar to the whole class. We have the random state 123, and then we gave the we use the X train and X test with Y train and Y test, and then we specify the size and the random state. And then for number 4b, please check the first 5 rows. Same idea as which one was it? Same idea as this one right here. We using the head function. This one for train and this one for test. This is for X and this is for Y. Y train and Y test. Same idea, just different variable names. And for 4c, check the length of the X train and X test. For the length, we use this function here, len, and it is 20 and 30. Now number 5, please convert. For converting, we use label encoder to convert all the sets into one category, and here we specify the name as specified up top here. One for train label and one for test labels. Then question number 6a, please define a sequential model that contains 3 dense layers. We have the 3 dense layers here. The first one is it uses 100 neurons. Second one, same idea. Third one, only 3. And we are using softmax because we have multiple softmax right here, because we're having multiple classifications, right? So this is needed in here. And now please compile your model using RMS prob, an appropriate loss function, and accuracy for the metrics. So we're using the RMS prob optimizer in here with the loss function in here and the metrics accuracy right there. And then we have please fit your model using epoch 20 and batch 10. So for epoch 20, here we set epoch to 20 and then the batch size to 10, which gives us the this output right here. Now moving to number 8, please calculate the result evaluating your X test and one hot test label and see how accurate your model works. Okay, so we specify the one hot test labels, and then it gives us the outputs, the array, and then here we have the model evaluate, which outputs that over here. It shows us the accuracy, lost, and the 275 per step. My computer, okay. And now we are moving to number 9. Repeat all that we have done in 6 with the following parameters. So it's basically same thing, just different parameters. We're having 10 here, 10 neurons, and here 3. We're using Relo and Softmax as well. And then use the same setting as you have done for 6B, same idea for that one. Please fetch your model using epoch 3 and batch 10. This is also similar to something we have done earlier. I just lost track. So we're just using epoch. We set epoch to 10 and batch to, epoch to 4 and batch to 10 right here. And also this one is similar. Calculate the result evaluating the X test on the hot test label and see how accurate your model works. And then number 10, please explain all you have learned from this assignment. There are some questions that could answer how the number of layers or hidden units could impact the accuracy of model, and do we always suffer from overfitting, and how can we find the managing overfitting. So basically all we've done here is related to the topics that we have done in class, and by following your videos and the videos that you share and your lecture recorded lectures. It was pretty convenient for me to come up with all of these solutions in here. I had to watch your videos multiple times, but it still worked for me. And then yeah, and here we have for compiling, we use sparse category cross trophy, and then the optimizer's atom metrics is accuracy. And that's pretty much it.